In 1967, a physicist discovered something terrifying. He wrote the equations of the Big Bang on a blackboard, and then ran time backward. When he pushed it all the way back to second zero, the equations gave an answer: the volume of the universe was zero, the density was infinite, and the temperature was infinitely high. These three numbers existed simultaneously. In physics, this is called a singularity, also known as the end of physics itself, because at this point, all physical laws completely break down. It's like walking to the edge of a map in a video game, only to find nothing ahead, just a blank void. And if you take one more step forward, you don't fall off the map, you simply vanish from the game entirely. What's even more unsettling is what quantum mechanics tells us. Before something is observed, it does not truly exist. So what existed before the Big Bang? The answer might be that the universe was waiting for its first observer. And that observer might be you, 13.8 billion years later. But scientists were not satisfied with such a romantic answer. They uncovered something even more radical. The universe may have been born from nothing. And this nothing is far stranger than any emptiness you can imagine. You might think that nothing means absolute emptiness. But quantum mechanics says absolute nothingness does not exist. Even the emptiest region of space, at extremely small scales, is constantly boiling. Particles and antiparticles pop out of the vacuum like foam, and then annihilate each other in an instant. This is not theoretical speculation. It is an experimentally verified fact. In 1948, Dutch physicist Hendrik Casimir predicted that two metal plates placed in a vacuum would experience a mysterious attractive force. In 1997, scientists actually measured this force. What does this mean? It means the vacuum is not empty. It is a never-ending quantum soup. Now the question becomes, if even nothing is not truly empty, could the universe itself have accidentally boiled out of this soup? In 1973, a young physicist named Edward Tryon published a paper just 2 pages long in the journal Nature. He proposed a shocking idea. Our entire universe might be nothing more than a single quantum fluctuation of the vacuum. Yes, you heard that right. The entire universe, 100 billion galaxies, countless stars and planets, including you watching this video right now, may have been nothing more than the vacuum sneezing once. But there was a fatal problem. The law of conservation of energy tells us that energy cannot come from nothing. So how could an entire universe pop out of zero? Tryon offered a brilliant answer. The total energy of the universe is actually zero. Wait, there are so many stars, planets, and radiation. How could the total energy be zero? The answer lies in gravity. The mass of matter represents positive energy, while gravity represents negative energy. Imagine lifting 2 stones from the ground up into the air. You must expend energy to do it. In other words, objects bound by gravity are effectively in debt to the universe. Stephen Hawking explained it this way: the positive energy of matter in the universe and the negative energy of gravity add up to exactly zero. It's like borrowing $100 from a bank with your left hand and immediately repaying $100 with your right hand. On paper, you created nothing at all. If this is true, then the birth of the universe required no net energy. A quantum fluctuation could spontaneously create a universe without violating any physical laws. Nobel laureate Tryon later summed it up with a famous line: the universe is simply one of those things that happens from time to time, but from a tiny quantum fluctuation to today's observable universe, 93 billion light-years across. What happened in between? This brings us to one of the most important theories in cosmology: inflation theory. In 1980, American physicist Alan Guth proposed that right after its birth, the universe underwent a brief period of insane expansion. How insane? In less than 10^3^2 seconds, the volume of the universe expanded by a factor of 10. How fast is that? As an analogy, if you held a single atom in your hand, after inflation it would become larger than the entire observable universe. And this expansion was actually faster than the speed of light. Don't worry, this does not violate relativity. Relativity only says that matter cannot move faster than light. The expansion of space itself has no speed limit. Guth later called inflation the ultimate free lunch, because you get something from nothing, and you don't pay a single cent. Inflation theory is not scientific fantasy. Its predictions have been precisely confirmed by measurements of the cosmic microwave background. What is the cosmic microwave background? It is the afterglow of the Big Bang, a snapshot the universe took of itself when it was just 380,000 years old. The temperature patterns in that image match the predictions of inflation theory perfectly. But inflation solved one problem and created a much bigger one. If inflation can create one universe, could it create infinitely many? According to inflation theory, the inflating field does not thin out as space expands. Its density remains constant. When the inflating region grows by a factor of 3, 1/3 of it decays, triggering a Big Bang, and creating a universe. The remaining 2/3 continue inflating, continue doubling, and continue decaying. This process never stops. That means beyond our universe, there may exist infinitely many parallel universes, each with completely different physical laws, different particles, and even different concepts of time and space. This is not science fiction. It is a mathematical consequence of inflation theory. Cambridge physicist Alex Vilenkin is one of the founders of multiverse theory. He showed that most inflation models lead inevitably to eternal inflation, the endless creation of new universes. But there is another possibility. Maybe the universe had no beginning at all. Maybe it is cyclic. British physicist Roger Penrose proposed a theory called conformal cyclic cosmology. He argues that in the distant future, when all matter has decayed, when all black holes have evaporated, the universe will become empty and cold. But through a remarkable mathematical transformation, this end state can be reinterpreted as the beginning of another universe. Penrose even claims to have found traces of a previous universe in the cosmic microwave background. He calls them Hawking points, possible remnants of black hole evaporation from a universe before ours. There is also the Big Bounce theory. It suggests that our universe was born from the collapse of a previous universe. When that universe contracted to an extreme state, instead of hitting a singularity, it bounced back like a spring, creating our Big Bang. If this is true, the universe is like an eternal beating heart, contracting, expanding, then contracting and expanding again, forever. So which theory is correct? Did the universe really come from nothing, or has it always existed, with no beginning and no end? In 2024, scientists at the Perimeter Institute published an important paper. They showed mathematically that under certain conditions, the Big Bang singularity may be nothing more than an illusion. Light may actually be able to pass through this boundary. This means spacetime before the Big Bang may truly have existed, and may even be observable. Also in 2024, physicists at the University of Texas proposed that dark matter may have existed before the Big Bang. Their models suggest that dark matter particles formed during inflation, earlier than we previously believed. If this theory is confirmed, it would completely rewrite our understanding of the origin of the universe. Right now, the James Webb Space Telescope is observing the oldest galaxies in the universe. Data left behind by the Planck satellite is still being analyzed. Physicists around the world are designing new experiments, trying to detect primordial gravitational waves in the cosmic microwave background. If they succeed, we will directly see the universe as it was at the moment of the Big Bang, less than 1/10 quadrillionth of a second afterward. More than 300 years ago, Leibniz asked a question: why is there something rather than nothing? Today, physicists are finally offering an answer. Perhaps nothing itself is unstable. In the quantum world, absolute nothingness cannot exist. It is destined to fluctuate, destined to boil, destined to accidentally erupt into a universe. We may be nothing more than a bubble in an infinite void, a ripple that emerged from nothing 13.8 billion years ago. But within that ripple, stars were born, planets were born, life was born, and you were born. Thinking about where the universe came from, Stephen Hawking once asked, what is the boundary of the universe? And what answer could be more extraordinary than having no boundary at all? Perhaps the universe truly has no edge, no beginning, and no end. It simply exists eternally, and we happen to awaken at this moment, open our eyes, and see this astonishing world for the very first time. And this very act of observation, right now, may be the moment that makes the universe real.